So, we have learned about the wave properties of electrons and in general wave properties of matter. And today we will learn pretty much last bit about the light. Related to light, we will learn about the energy levels of the atoms. Energy levels of the atoms. And let's consider a few things. We have learned what happens if we have electric charge moving with acceleration. What happens when we have electric charge moving with acceleration? How electromagnetic waves is created? With accelerated electric charge, because create change in electric field, which in turn create change in magnetic field, and so on. So when we have that electric charge accelerating, it's emitting electromagnetic wave. Now, if you consider the model of atom, of course it's very simplified. Now we know that it is not really how the atom works, but for simplicity's sake, we have nucleus and we have negatively charged electron moving around. What kind of motion is that?
Circle.
Circular motion. So is it motion with acceleration? Even if it will be moving with a constant speed?
Yeah.
Motion with acceleration. And what should happen if the charge moving with acceleration?
Electromagnetic wave.
It should emit electromagnetic waves. So we should have all the time, all atoms emit electromagnetic waves. It's not the case. One thing. Second thing, if it will emit electromagnetic wave, what will be happening with its energy?
Reducing.
Reducing, and then it should eventually start smaller orbit and falls on the nucleus. Which is not happening. So that's one thing that requires answer. Why electron in the atom? If you take electron out of the atom, we accelerate it, it's emit electromagnetic wave. But if you have an electron accelerating inside the atom, it does not emit electromagnetic wave.
It doesn't go around. It doesn't have circular motion.
No. If you consider, there's a simplified version. Yes, now we know that this is a very simplified version. And what's happening in reality more, like closer to reality, we'll discuss later on. But that's what was beginning of the 20th century, and how the atom was, structure of atom was considered. And so that's one thing, why electron not emitting electromagnetic wave when it is accelerating inside the atom. That's one thing. Second thing, we know that every element, every chemical element, when it is in the state of gas, and it's emit different wavelengths, different electromagnetic waves. So, for example, let's have a look. Can you please turn light off? Can you please turn light off for a second? So, in this case, we have this tube is filled with hydrogen. We connect electric current. We have one color, light. Then we take another element. Let's say this is mercury. So this glass tube filled with mercury, and we see it's a different color.
Really? Looks similar.
If we, let's say, take a sulfur, it's different color. No, you can see they clearly have different.
Different shades.
They're all little bit sort of pinky present, but and now we'll put helium.
Green.
No,
Another shade of purple.
Oh.
and this one you clearly different.
Is that what they put in like neon signs?
No, they put.
Yes, if you put neon, there will be another color. So, can you please have light effect? So different elements, what's important in the atomic state, so in the gas and in the atomic state, they emit light with the different colors. So it all very well known that emission and absorption spectrums of elements okay, so this is continuous spectrum. But for example, if you look on the spectrum of hydrogen, emission spectrum, it emits only certain wavelengths. Yes.
What do you mean like emission? Like how?
That's what you've seen when we have gas and we somehow give energy to it for one of the way, in this case, I connected electrical current through the gas, and this gas give energy, and so that it's emit light. You've seen it was producing light. But it's producing only certain wavelengths. If we will have a hydrogen gas, we're not like connecting electric current, not heating up, but we send just continuous spectrum through the hydrogen, we will see that it will absorb light exactly same wavelengths as it's emitting. So all light will come through except those black lines means that light of those wavelengths did not come through the hydrogen. It was absorbed. If you look on, for example, helium, it has completely different set of the wavelengths. Look on the, let's say, mercury. It has completely different set. This is like a passport for element. And in chemistry, we probably learn about spectroscopy, and that's how we can find which chemical elements are in the gas, looking on its emission or absorption spectrum. By the way, why helium called helium? Why it was named helium?
Great grass.
From Helios, sun. But why it was named after the sun? Why helium was named after the sun?
Converts hydrogen. Doesn't the sun convert hydrogen?
Yes, but it was named because helium was discovered on the sun before it was discovered on Earth. How we discovered? Looking on the spectrum of the light, we have found that there are lines in those spectra, because those lines are unique for each element. It's like a passport of element. If you have set of lines, and we have a table, we can compare and say, here we have, in this gas, we have mercury, we have hydrogen, we have nitrogen, and so on. But there was, in the sunlight, there were lines representing unknown element, which was called helium, from Greek helios, the sun. And only later, helium was found on Earth. So it was discovered through its spectrum in the sunlight. Now, how we can explain those things? One thing, that there are no continuous electromagnetic emission of atoms. Electrons not falling on the nucleus, but when we have atomic gas and we heat it up or send electric current through it, it emits only certain wavelengths and then absorb exactly the certain wavelength, certain number or certain wavelengths, certain set of wavelengths for each element. And then Niels Bohr came with the explanation. Said that electron in the atom cannot have any energy. It can have only certain fixed energies. Can be only at certain energy levels. When electron is on this permitted energy level, it does not emit any electromagnetic wave. Let's consider some element and that has, let's say, 4 energy levels, 4 permitted energy levels. Let's start, take the lowest one, often called ground level. Let's say that it's 0 electron volts. This will be, let's say, 10 electron volts. This will be 12 electron volts. This will be 13 electron volts. So, if electron is at any of those levels, has that energy, it does not emit electromagnetic wave. But if it drops, for example, we somehow excited it to some level. When it drops from this level down, it cannot be anywhere in between. It can only drop from this energy level to some lower energy level. What is change in energy? 10 electron volts. That means then photon of light will be emitted with the energy exactly 10 electron volts, which correspond E equal hc on wavelengths, which correspond some particular wavelengths. Then, if we send continuous light, the light with photon energies less than 10 in between will not excite electron, they cannot be absorbed. But if we have coming photon with energy 10 electron volts or 12 or 13, let's say we have send light with energy of the photon 13 electron volts. Then we will have electron will absorb it and go up to this level. It's absorbed.
What about like 14?
No,
No.
it will not be absorbed by the atom.
Right.
No, unless there are some
Yeah.
some more levels. So it will not be absorbed by the atom. Now, how many, if you consider the electron, doesn't matter how we excite it, electron to the 4th energy level here. How many, and it's dropping, it doesn't have to drop straight to the ground level. It can drop gradually through the other permitted energy levels. How many different photons of light, so how many different wavelengths can be emitted?
4.
1, 2, 3. Then after it drops here, it can drop here, or it can drop here, or drops from here. How many total possible?
7.
6.
1, 2, 3, 4, 5, 6.
Oh, yes.
So there will be, this atom will be able to emit 6 different wavelengths.
2 and minus 1.
6 different wavelengths. Now, and I will name this is a ground level. This is the first excited, second excited, third excited. Which transition of the electron will produce the light with the longest wavelength? Yes.
12.
10. 10 to
Which transition from where to where will
12,
produce
13
long?
is 12.
12. Yeah. Yes.
E equal hc on wavelength. So longest wavelength will be produced with the smallest energy, which is the smallest transition here?
13.
1 from 13 to 12.
That's what we said.
Hmm?
We said 13 to 12.
13 to 12, sorry,
Yeah,
I misheard. So, the longest wavelength will be with the electron, with the photon energy 1 electron volt. Can you please calculate its wavelength? Can you calculate wavelength will be equal 4.14 times 10 negative 15 times 3 times 10 in the power of 8 Hc over energy divided by 1, pretty much is 12.4 times 10 negative 7, 1.2, something like 25 times 10 negative 6 meters, I think.
Yeah, 1.24. but-
1.24. That will be light, longest wavelength emitted for this particular atom. What will be the shortest wavelength emitted?
13 to 0.
When we take transition from the 13 to 0. So if we put here 13, we divide by the
9.
biggest change in energy,
9.
and then we will get will be about 9 point something like 85
Oh.
times 10 negative 7. Can you check?
9.55, 10 negative 8.
5,
10 negative 8.
10 negative 8 meters.
Right, is this for the longest or the shortest?
This will be the shortest wavelength. Yes.
And what's the longest? What's actually happening? Like, I don't really
So what
understand.
happens? Electron, there are in the atom the only certain energy levels permitted. Electron can be at the ground level only, or at this level, or at this level, or anywhere in between. It's prohibited. Electron cannot be. So we can have electron can move, absorb some energy, either from the photon or from other way, and go up,
Up in
absorb energy. Or it can go when after it's excited, it can drop down, and then it will emit photon with exactly same energy as it absorbed to go up.
It goes up in energy, is what you're saying.
Yes,
Okay.
at the higher energy levels. At the higher energy levels.
So the
Yes.
higher you go up, the smaller the wavelength is, basically. Like the higher energy.
The smallest.
Yeah. Oh,
Gap, you're talking about gaps.
yeah.
The smaller the gap of the transition of electron, the smaller the gap, the longer will be wavelength. The bigger the gap, the shorter will be wavelength emitted, and higher energy of the photon. That's why, because this set of the energy levels is unique for each element. That's why each element produces only certain set of the certain wavelengths. Yes.
So the longest wavelength would be 13 to 12 electron volts, so it'd be 1, like it'd be over 1.
Yes.
The longest wavelength will be over the smallest change in
Yes,
energy,
one.
over 1. The shortest wavelength will be, if it will be over biggest change in the energy, 13 electron volts. Now, why there can be only certain energy levels, not anything in between? And now, it is because of the wave properties of the electrons. It is because of the wave properties of the electron. If you can see the electron not as a particle, not as a small ball moving around the nucleus, but you can see it rather as a wave going around the nucleus. And only orbits will be stable where standing wave can form. So only if the circumference of the orbit, which is equal to pi r, if it will be equal whole number of the wavelengths. Remember the condition for constructive interference, condition for antinode, it has to be
Circumference.
the circumference of the orbit must be equal to whole number of the wavelengths. If it's not, then the standing wave will not form, the wave, electron wave will cancel itself out. So only in this case, example, if let's say n equals to second energy level, so 2 wave, it will look something like this.
Wait, so the circumference has to be, n times
We
wavelength.
have two,
The circumference has to be n times wavelength for it.
circumference, which is formula for
Yeah.
circumference 2 pi r, has to be equal whole number of the wavelengths of electrons
For it to what? So,
to form standing wave and make a stable orbit. So this is one possibility. This is the second energy level when we have two wavelengths going around the orbit. That will look, if we have three, that will be third energy level, like 3 wavelengths going around the.
Wait, hang on.
I'm not the best artist.
What is going on here? Like, I don't.
This is electron. This is around the orbit. We have 2 wavelengths fit in the orbit. So when around electron going around the nucleus, this
Yeah.
is the orbit,
Yeah.
which is not exactly correct talking about the orbit of
Is this how like
electron.
the whole like butterfly thing in chemistry happens?
yeah.
It's like the different shapes of orbits and stuff.
Yes, that's actually where those things come in chemistry from physics.
Yeah.
That are, in fact, which is very beyond school curriculum, we can talk only about the probabilities of electron being at a certain place. And all those shapes that you've seen in chemistry of those orbits, it's actually sort of the probability cloud, where we can talking only about the probabilities of electron being there more than probability of electron being there.
Yeah.
So, but this is another proof of the wave properties of electrons. Only if along the orbit we can have 2 waves, or 3 waves, or 1 wave completely fits in the orbit, then when it go around, we will have that it starts, let's say, at crest, make 2 waves, and crest will meet crest. If we have orbit, again, it's simplistic for better understanding idea. It's a little bit more complicated than that. But if you say orbit is 2 wavelengths, we have 2 waves coming. So if it starts from the crest, from the maximum, it's going 1 time, second time, but it's going 2 ways, but it's going in circle. This wave going around, not going straight, going around. And if when it's went around the orbit, then you will have crest meet crest. If it's exactly fit in the orbit, imagine we have this, and we turn it around. Crest meet crest, what we'll have? Constructive interference. We have standing wave created. Such orbit can exist. But if we will have that orbit, some orbit, is not exactly 2 wavelengths, let's say only 1.5 wavelengths, what will happen then?
Destructive.
We have destructive interference and the electron wave will cancel itself out. So for orbit to exist, and each energy level associated with this, we need to have whole number of the electron wavelengths, reminding that the formula for electron wavelengths or de Broglie's wavelengths equal h on p. Only those orbits can exist. Electron can only go between energy levels. It cannot be anywhere in between, because then if it's in between permitted energy levels, the standing wave cannot form and the orbit will be unable to
Go to like
exist.
infinity.
Yes.
So it, wait, they almost.
You can first.
So at each energy level, there's constructive interference.
Yes, to have energy levels exist, standing wave must form. So constructive interference of electron wavelengths with itself must happen. No.
When you say standing wave, is that just the circumference? Like that's the wave, standing wave?
Because remember what is standing wave. When
Yeah.
yeah. So we have that with a string, and if it's fixed at both ends, this standing wave this will exist such way. But if you make in the way that it's something like this, and the end will be, another end of the string will be somewhere here, then it will not exist. Standing wave will not form.
So the circumference the electron travels around is the standing wave.
Yes, yes. So only when electron wave going around the orbit can form standing wave, such, and condition for this that the length equal whole number of the wavelengths, pretty much similar to what we have with the string fixed at both ends. Such orbit can exist. Yes.
Well, two questions. Why are there different like differences between each level, and also why is there only like a certain set number of levels? Because if it's just n times wavelength, can it go forever?
No, it's not. It's not infinite number, because for each atom, if we will look on the energy levels, ground, then another, then another, and then we will have ionization. If electron get too much energy, atom becomes ionized. Electron will leave the atom. So that is, if you get energy for electron enough to this, and for each atom it is say its own level of ionization, the electron will get out of the atom, and atom becomes an ion. And then, if we, from here onwards, will it be the discrete line, discrete energy levels after that, above ionization?
What do you mean?
Correct. No, because there is now no orbit. It's a free electron. So above ionization can be any energies. There is no energy levels for free electrons. It's only for electrons in the atom. Yes?
So the standing wave that is in the, like, that's the orbit around the nucleus, that is the electron.
Yes. This is standing wave,
But there
is
is no-
electron.
There's no.
And what we get used to saying electron is a particle, so small ball. It's actually not. Sometimes it behaves like it. Sometimes it behaves as a wave. Everything as a light behave as a wave and as a particle. In the microworld, like subatomic world, everything have both properties, particles and waves. Yes.
So why are the levels different?
While levels different for different chemical elements.
No, like why is it like 10 then to like the gap between?
Why it happened that the
Space.
spacing becomes less when you're going up? That calculations will show. That's how it is, and we can do calculation, but they will be also. The levels become closer there. It's not always the next gap will be smaller. Sometimes it can be a little bit bigger, but overall the gaps when we're going up, gaps decreasing overall. That can be done, as I'm saying, with the calculation which will be on screen. Yes.
So when electron is ionized, there's no energy level.
No, it's a free after ionization level. If you give energy for electron enough to leave atom,
Yeah.
then there is no condition for it to make a standing wave. It's free. So that is energy levels of the atoms. Like, subscribe, and donate to help fight terrorist countries and organizations, support Ukraine and Israel.